So good day everyone. So I am here currently recording our lesson because um, the face-to-face classes were suspended, probably because some of the teachers were on seminars also. And so our lesson for today will be about the Bronsted acids and bases and acid-base property of water. This was actually discussed already with the Set A students of STEM B, if I'm not mistaken. But then we were not able to finish. That's why I am recording this. Recording. That's why I am recording this video lesson for everyone. So let us define what is Bronsted-Lowry theory. Ito yung una. Sabi dito, in chemistry, the Bronsted-Lowry theory describes acid-base interactions in terms of proton transfer between chemical species. So, if you are going to recall, kung babalikan natin yung lesson ninyo way back in junior high school in General Chemistry 1, usually you can identify an acid because of the presence of the H, of the hydrogen, while you can identify a base because of the presence of the OH or the hydroxide. But in the Bronsted-Lowry theory, it presents a different point of view on how we can identify what an acid is or what a base is. So let's move on. Ito yung sunod. This was proposed by Johannes Nicolaus Bronsted and Thomas Martin Lowry in 1923. So Bronsted acid is a substance capable of donating proton. So take note of that. Pag sinabing Bronsted acid, nagdodonate siya ng proton. And in this case, it's always the H plus ions. And a Bronsted base is a substance capable of accepting a proton or the H plus ions. So thus, these descriptions are basically appropriate for a discussion on the properties and reactions of acids and bases. So you will know later na yung tinutukoy ditong proton is only the H plus ion. So let's continue. So here, so addition to the Bronsted definition of acids and bases is the concept of the conjugate acid-base pair, which can be defined as acid and its conjugate base or a base and its conjugate acid. So we'll have an example for this para mas malinaw nyo ma-visualize what a conjugate acid is or what a conjugate base is. Now, the conjugate base of a Bronsted acid is the species that remains when one proton has been removed from the acid. On the contrary, a conjugate acid results from the addition of a proton to a Bronsted base. Ito yung example. So, every Bronsted acid has a conjugate base. So, ibig sabihin, kung merong Bronsted acid, meron siyang palaging kasunod na conjugate base. And every Bronsted base has a conjugate acid. So, let's try to have this example. Try natin to. Ito. Okay, so we have HCl or hydrochloric acid. Ito yun. Plus H2O, which basically is water, will yield, ganyan yung arrow niya dapat, hindi isa lang na arrow, will yield H3O or the hydronium ion plus the chlorine ion. Now, let us try to identify what are these Bronsted acid, conjugate base, conjugate acids in here. Okay, according to this one, the chloride ion is the conjugate base. Eto, nakita nyo. Chlorine ion is the conjugate base formed from the acid HCl. Galing sa HCl, naka-form lang ng chlorine ion. And then, the hydronium ion, this one, is the conjugate acid of the base H2O. Ayan. Now, take note that water here acts as a base. So, paano kaya ito nalaman? Paano mo malalaman kung alin yung acid base, alin yung conjugate acid, alin naman yung conjugate base? Sige, let's move on to the next slide. Okay, so in this next slide, nawala na yung arrow natin. Lagyan ko muna ng arrow. Ayan. Okay, so the Bronsted definition also enables us to classify ammonia as a base because of its ability to accept proton. Eto. Ammonia daw is the base in this example. So in this case, NH4 is the conjugate acid of the base NH3. Ayan, yung NH3, siya yung base, kaya naka-form siya ng conjugate acid na NH4+. And the hydroxide ion, this is the hydroxide ion, is the conjugate base of the acid H2O. Based doon sa H2O, naka-form siya ng conjugate base. From H2O, it then formed hydroxide. Note that the atom in the Bronsted base that accepts an H plus ion must have a lone pair. Ayan. So let's move further. Ito another example. So you can try on your notebook. So you copy the example and then try to answer on your notebook. Sige, pero at this moment, kung ano pa naman, okay lang naman kung magkamali pa kasi hindi pa naman ito yung pinaka-final round, kumbaga. Okay, let's have the example. Example number 2. Identify the conjugate acid-base pairs in the reaction between ammonia and hydrofluoric acid in the aqueous solution. Ito yon. We have the NH3, the ammonia. We have the hydrofluoric acid. Now we have the ammonium and ammonium ion, and we also have the fluorine ion. Sige nga, ano kaya dyan yung acid? Alin dyan yung base? Alin kaya yung conjugate acid? Alin naman yung conjugate base? Sige. Ayan, sunod. Now, the strategy here is remember that a conjugate base always has one fewer H atom and one more negative charge than the formula of the corresponding acid. In my case, meron akong tinatawag na add. Ang pangit ng sulat. Add ba. Hindi ko nasabi kanina doon sa lesson. I was so overwhelmed and very excited to the point na nakalimutan ko ibigay itong add ba. Ano ba itong ibig sabihin ng add ba? Now, letter A stands for acid. Ang hirap pagsulat. Ayan, acid. Now, the letter D stands for donates. Sana naiintindihan yung donates, yung sulat. Pero sinasabi ko naman, hope you will get it. Donates. And then yung B naman, tinatawag ko siyang base. And then yung A, siya naman yung accept. Ayan. Nagtamad na po. Okay, so ADBA. ADBA stands for acid donates, base accepts. May S yan. Ayan. Okay, so let's try this one. Sabi ko, pag acid, nagdo-donate. So, tingnan natin dito sa equation. So, let's have the pair first. NH3, syempre, yung na may-yield niya, syempre, NH4. And ito naman, HF, yung may-yield niya is F. Tingnan natin kung itong NH3 nag-donate or nag-accept. Nung nasa other side na siya ng reaction, nadagdagan siya ng hydrogen. Meaning to say, nag-donate ba siya or nag-accept? Kung sinabi mo nag-accept siya, tama ka. Ibig sabihin, ang NH3 natin, since nag-accept siya ng proton, ibig sabihin, ito yung base natin. Kasi nag-accept siya, hindi naman siya nag-donate. And so, since ito yung base, obviously, ito na yung acid natin. Tingnan muna natin. Ito naman na HF, nung sa kabilang reaction, nawala yung H. Ibig sabihin, nag-donate siya. Kaya obviously, HF is our acid. Excuse me. Okay. So, meaning to say, since NH3 yung base, that makes NH4 our conjugate acid. And then, since ito naman yung acid natin, yung NFH, hydrofluoric acid, that makes our F our conjugate base. Sige, answer reveal. Tapos mali yung sagot ko. Tingnan natin sa answer reveal. Okay, sabi dito, NH3 has one fewer H atom and one fewer positive charge than NH4 one fewer H atom, and one more negative. Therefore, the acid-base pairs are NH4 and NH3, tama tayo, and HF and F. Okay, tama naman yung pair na na-identify natin. So we have a different set of activity for the previous topic. I-insert lang muna natin itong acid-base properties of water. So water is a special molecule and has many unique properties that make it essential for all life on Earth. In fact, when scientists look for life on other planets, they first look for signs of water. One of its special properties is its ability to act either as an acid or as a base. Now take note of that. So if you are going to take a look at the parang scale ng mga compounds, water is always placed at the center with regards to its pH. But then take note that water can either be an acid, can act either as an acid or a base. So water functions as a base in reactions with acids such as hydrochloric acid and acetic acid. And it functions as an acid in reactions with bases such as ammonia. Ayun, yun sa acid-base properties of water. Now moving on, water is a poor conductor of electricity because it is a very weak electrolyte. But it does undergo ionization to a small extent. Ayan. So I forgot to mention that when you see this symbol, yan, iba yan doon sa symbol sa normal chemical equation na natutunan nyo way back in junior high school or way back in your general chemistry. Ibig sabihin yan, merong pangyayari, merong tinatawag na, I forgot the term, what was the term again? So it's the equilibrium. Meaning to say, yung water na ito may form H plus and OH negative ions and then pwede siyang bumalik din agad-agad. Parang ganyan yung nangyari. Kaya yung araw niya pa ganyan, then may pa ganyan. So, depende sa reaction rate. Amo po. Okay, so this reaction is also known as autoionization, partial ionization. Within the framework of Bronsted, autoionization of water can be explained by the following equation. Ayan. Merong acid plus base na water, and then meron na form na hydronium acid, and then the hydroxide base. Okay, so let's move on. So here, one water molecule acts as an acid and another water molecule as a base. Therefore, the conjugate acid-base pairs are H2O acid and OH base 1, and number 2 is H3O, that's the acid 2, and H2O as the base. So let's try to perform activity number 1. Am I an acid or a base? That's the title of our activity. So the direction here is identify the Bronsted-Lowry acid and the Bronsted-Lowry base in the following chemical equations. Sige. Now on your notebooks, I'd like you to write these chemical equations and then try to identify which from this equation is the Bronsted-Lowry acid and which is the Bronsted-Lowry base. So you can pause this video para mabigyan ka ng time mag-isip kung alin yung sagot. Then after, pwede mo na ipagpatuloy for you to see what is the answer. Now I have placed in here this one. Remember ABDA. Acid donates, base accepts. You can now start pausing this video. So given na tapos na kayo magsagot, let's now reveal the answer. This is the answer for number 1. The acid is C6H5OH and the base is NH2 negative. Sige, gamitin natin yung concept ng ADBA. Okay, so sabi ko, pag ang acid pag nag-donate siya, acid 'yon. Pag nag-accept siya, that's base. So let's see. Yung counterpart ng C6H5OH dito is obviously ito, C6H5O. Nawalan siya ng H, meaning to say, nag-donate ng H si C6H5OH. So that means, correct, siya talaga yung acid. On this side naman, NH2, from NH2, naging NH3 na lang siya. From NH2, naging NH3 siya. Ibig sabihin, nag-accept siya ng proton. And that makes NH2 as our base. Okay, gets? Let's have the second example. Ayan naman. Sabi dito, yung acid dito is AlH2O. H2O6 3 plus H2O will yield Al H2O5OH 2 plus H3O. Ito yung binabasa ko. Ayun. Sabi dito yung acid dito is Al. Ito yung acid. Bilugan ko para malinaw. Yung counterpart niya sa kabilang equation, ito. Na para malaman natin kung acid ba talaga siya, bilangin natin yung number of hydrogen. In this case, yung hydrogen dito is 6 times 2 is 12. Meaning to say, meron 12 hydrogen dito sa una. Bilangin naman natin dito sa ikalawa na pagkahaba-habang chemical equation. So, 2 times 5 is 10. Meron ng 10 hydrogen. Plus 1, 11. So, meaning to say, mas marami yung hydrogen dito sa nauna. So, since dito, nawalan siya, ibig sabihin, nag-donate siya. So, that makes this one as the acid. Ito naman, yung hydrogen na dito is 2, dito naman 3. Ibig sabihin, yung H2, nag-accept siya ng proton, and this makes H2O as the base. Okay, moving on with number 3. So, dito naman sa number 3, yung acid is H3PO4, and the base is OH negative. So, tingnan natin, yung counterpart ng H3PO4 is H2PO4 negative. Yung counterpart naman ng OH negative is H2O. So, in this case, H3PO4, meron tatlong H. Dito naman, merong dalawang H. Ibig sabihin, nag-donate. Kaya ito yung acid natin. Ito naman, from OH, naging H2O. Nadagdagan siya ng H. Mean to say, nag-accept siya. Mean to say, OH becomes the base. Okay? And the last one here, the acid is the H2O and the base is the NH2. Tingnan natin. Yung NH2 dito, NH2 negative, yung kapartner niya obviously is NH3. Yung H2O naman dito, yung kapartner niya is OH. Kaya tingnan natin, yung hydrogen dito is 2, dito naging 3. Meaning to say, nag-accept si NH2 ng proton and that makes NH2 as the base. Dito naman, sa H2O, naging OH na lang, nawalan siya ng isang hydrogen, meaning to say, nag-donate siya. Kaya that makes H2O as the acid. Okay, gets? Moving on. Dito naman sa isa, in the following equilibrium, HpO4 negative 2 plus HSO4 negative 1 yields H2PO4 negative 1 plus SO4 negative 2. So, identify each Bronsted Lowry component. Alin kaya dyan yung acid? Alin kaya yung base? Alin yung conjugate acid? Alin naman yung conjugate base? You can pause this video para mag-start na rin kayong mag-isip kung alin yung sagot. Given na pinost nyo na at pick-play nyo na yung video, let's now have the answer. Our acid here is, ay, lumabas lahat ng sagot. O isa-isahin natin. Alin yung acid ba dyan? Tingnan natin. Simulan natin sa HpO4. Yung kapartner ng HpO4 is obviously H2PO4. Yung kapartner naman ng HSO4 is SO4. Dito, titingnan niyo yung hydrogen is only 1, pero sa kabila, naging 2 na yung hydrogen, meaning to say, nag-accept siya ng hydrogen. And since nag-accept siya ng hydrogen, siya ang ating base. And dahil siya yung base, automatic yung kapartner niya na H2PO4 is the conjugate acid. Tama ba? Tingnan natin. Yung base, okay, eto. Then, yung conjugate acid, ayun, tama. And then, tingnan naman natin ito. Yung HSO4, isa lang yung hydrogen. Tapos, pagdating dito, wala ng hydrogen. Meaning to say, nag-donate sa HSO4. Kaya, siya ngayon yung ating acid. At since siya naman yung nawalan, siya yung conjugate base. At tingnan nga natin kung tama. Our acid is HSO4, correct? And then the conjugate base is SO4 negative 2. Ang galing-galing natin. Okay, so let's have now activity number 3, finding my partner. So identify the conjugate acid-base pairs in these reactions. Sige, pause nyo na yung video. Okay, given na pinost nyo yung video, eto yung sagot. Yung problema, natatakpan ng video ko yung sagot. Hindi nyo makikita, kaya isa-isahin natin. So, hinahanap lang naman dito is the conjugate acid-base pairs. So, madali lang naman yung tingnan. Yung SO4, eto yung kapartner niya. Yung PO4, eto naman yung kapartner niya. Eto naman dito sa C5H5NH, yung kapartner niya, ayun. Eto naman yung kapartner niya, ayun. Eto naman yung NH3, obviously yung kapartner na nandun sa dulo. And ito naman yung kapartner niya. Yung HClIO3, ito yung kapartner niya, and then yung kapartner niya man, ayan. So, ganun lang kasimple yun. Moving on. So, what is the relevance of studying acids and bases? Ano ba? Sige, isipin nga natin. What do you think is the importance of studying acids and bases? Where can we apply our knowledge of acids and bases? Ang dami. Simulan natin sa bahay. Simulan natin sa paborito kong part ng bahay, sa kitchen. Sa kitchen, ang daming acids and bases. So, let's start with a vinegar. Vinegar is an example of a acid. And then, pag nagbe-bake naman kayo ng cake, we have baking soda, baking powder. Those are examples of bases. And these are used for cooking. Excuse me. Pumunta naman tayo sa sa mga restrooms. Yung panglinis ninyo ng muriatic acid, that is an acid obviously. O di ba? Sa katawan kaya natin, yun importante. Sa tiyan natin, meron tayong mga acids sa tiyan. And yung acid na yan tumutulong para ma-digest natin yung mga food natin. But in my case, I suffered from gastroesophageal reflux disease. Ibig sabihin, magkakaroon ka ng ganyang sakit pag yung acid sa tiyan mo, sobra-sobra yung production, to the point na tumataas siya, simula sa tiyan, papunta dito sa lalamunan. Kaya minsan, yung parang merong plemang nakalagay doon sa lalamunan mo because that is due to the acids na tumaas. Or kaya minsan, palagi kang nauubo, parang ganyan sa throat mo. That's the acid, tumaas na kasi. Or worse, it causes bad breath. Yun. It's not the cavities in your mouth. It's actually the acid reflux. Kaya minsan, bali, mapagutom na tayo. Wait, tara kain tayo. Amoy bituka na ako eh. Kasi, that's actually the amoy of the bituka. Yan yung nangyayari. Grabe yung acid production, tumataas na nagkakaroon ng acid reflux. So in your case, siguro you have experienced acid reflux, pero not so much kasi bata pa naman kayo. Hindi pa naman kayo sobrang matatanda. But then, be careful with this one kasi it could lead to other serious diseases. So if you want to research on, sige, fact check nyo para mas maganda. Okay, so let's have the wrap up now of our lesson for today. A compound that can donate a proton, like a pointer natin para nakita nyo. A compound that can donate a proton to another compound is called a, what's the answer? The Bronsted Lowry acid. The compound that accepts the proton is called a, what? The Bronsted Lowry base. The species remaining after a Bronsted Lowry acid has lost a proton is the conjugate base of the acid, and the species formed when a Bronsted Lowry base gains a proton is the conjugate acid of the base. Thus, unblank acid-base reaction occurs when a proton is transferred from an acid to a base, with formation of the conjugate base of the reactant acid and formation of the conjugate acid of the reactant base. Yung nakalagay po sa, finally you made it. Take your last step and good luck. Para magrarampa lang. So I hope you get the idea of our lesson for today, and I would appreciate if I would be able to see this in your notebook also. And because of that, to everyone, I say thank you. See you again in the next video, or much better, in our next face-to-face classes.